Okay, so now we are going to discuss JWT, right? And let's discuss JWT. It's JWT, right? JWT is also referred as JOT token, and it stands for JSON Web Token. So in this session, we are going to discuss what is JWT, how it is used, and um, how it provides the security to in OAuth 2.0. Okay, so before we start our discussion on the JWT, let's first understand the basics of the JWT, and let's see why it is required. Okay, so to understand that, let's we have to recall our discussion for the OAuth 2.0 code flow, right? So if you remember, in our code flow, or in our authorization grant type discussion, we discuss how your authorization server provides a access token to the client, so that client can use that access token to get the access to the protected resource. And that is where this JWT tokens come into the picture, and that is where it is used. So let's first once recall our OAuth 2.0 code flow. So as we know, one second. So as we know, in OAuth 2.0 code flow, client first send a request. Sorry, just give me a second. Something is not right with my digital pen. Okay, now. Yeah. That's not right. Yeah. So client first send the request to the authorization server on auth endpoint, and that is how your authorization server start the auth dance, and it uh, then send the request to the resource owner, so that the authorization server identify the authenticate the resource owner, and gets the consent for the client to give him access to the protected resource. So if authentication of the resource owner happens successfully, our server returns auth code, right? So suppose that auth code is 1234, right? With the help of this 1234 auth code, your client send another request to the authorization server, but this time on the token endpoint. Right now, how this happens and what all details your client sends in this request, we discussed it in our previous session, right? So if you do not remember, you can go and check that. Right now, here also your R server do some validation, and if all the validation is passed, then your token endpoint generates a access token, right? This is important, at least for this discussion, right? So your authorization server generates a access token, and it provides that access token to the client, right? Here is your access token, right? Your client use this access token that is provided by the authorization server, and it sends another request to the protected resource server, right, with this access token, right? With this access token, let me correct this. This go here, and this is my access token. All right, then your client send another request to the protected resource with same access token, right? Now protected resource need to validate this access token, right, before it give access to the client to the protected resource that is it is requesting for access. And it is very important, because if client get access token from some other server, may say suppose from the Yahoo authorization server, that access token should not be used on the Google to access the Google's protected resources, right? And it also need to, your protected resource server also need to validate the access token to make sure that this access token is not modified, or is not altered by the client, or client has not generated this access token by himself, right? So your protected resource will take this access token, right, and validate it before it give access to the client. Now how he will validate the access token? Obviously right now there is no other way. So your protected resource has to connect to his authorization server, right, to get this validated, right? So it will connect to the authorization server and says Mr. XYZ has provided me access token. Can you make sure, or can you validate this and make sure that it is generated by you, and it has all the required scopes and everything, right? So maybe authorization server was maintaining a database where it has stored the all the required information. So say suppose access token is generated abc, right, and it has all the information like the scope and who was it is who was the resource owner who authenticated and authorized this request and stuff like that. So everything is stored in the database. So your authorization server will look up that database entry, and if it's find that access token in the database table, it will return a success uh, response to the protected resource server. And once protected resource server get that positive response, it will give access to the client to this protected resource, or whatever protected resource it was looking for. So this is how it is, right? But no, this is not how it is. So if you see in this process there is a problem, and the problem is your protected resource always have to depend or connect to authorization server, and authorization server has to do this extra processing to validate this, right? And your protected resource has to wait until it get the response from the authorization server, right? So to remove this dependency and to remove this uh, to remove this uh, to remove this dependency and to remove this back and forth network calls, we have JWT, JSON Web Token, right? Now JSON Web Token is completely independent token, or it's completely independent entity, right, which provides all the information that protected resource need, right, to determine if to determine who the person who has or the resource owner who has actually authorized this request, right? It provides information what is the scope means what all access he need to provide to the client in this request, right? And who actually which authorization server has authorized this request, right? So all this information is contained in the JSON token that your protected resource can independently use to determine if client should get the access to the protected resource or not, right? And the most important thing is it don't need to connect to authorization server, right? We will discuss next that how it is possible, right? But before that, this is the theory. Okay. So in nowadays your authorization server returns the JWT access token. So actually it will be JOT, JWT access token to the client. Client sends this JWT access token to the protected resource server. Protected resource server parse this JWT token, right, and get all the required information which is need to give access to the client, right? And it also before it give access to the client, it makes sure that this JWT token is it's a secure. I mean, it is not created by someone else, or it has not been modified by the client or any hacker before uh, this token is get to the protected resource server, right? And JWT independently the JWT token can independently validate that. Now how it happens we will discuss, we will see next, right? So I hope now we know that why OAuth 2.0 use JWT token and how it is used, right? We'll look into the technical details now. Now before we discuss further, let's see how this JWT token look like, right? So let me quickly generate a JWT token. So I have a setup uh, that I have done on the Okta server, right? And in our session we will see how Okta server works and how we can integrate Okta with the Mule Anypoint Studio. But for now, just because our focus is only to understand the JOT token or JWT, so we'll look into only the specific part, right? So let me generate a JWT token so that we can at least see how it look like. Proceed. Yeah. So as you can see, this is my JOT token. Yeah. Here is my JOT token, right? Now we cannot read it right now, right? But there is a way to read it. So uh, if you go to this site, yeah, jwt.io, and paste your JWT token here, this site will use the the technique, right, and parse it for you, right? So this JWT token is passed into this format which we can read, right? So as you can see, JWT token has three parts. First is header, then we have then we have payload, and then there is a third part which we call the signature, right? So JWT consists of three parts, right? We'll discuss all three parts and we'll see how this site is able to read this JWT token, right? But first understand that yeah. JWT, and as its name suggests, JSON web token, right? So it's a JSON data, some data in the JSON format, right? JWT token has three JSON objects, right? Or I would say uh, three three parts, right? Complete your JSON JWT token has three parts. First is your okay. First is header, right? Then we have payload, and then we have signature, right? These three parts together called the JWT token, JWT token, right? And the JWT token is generated by token endpoint or by your authorization server. Okay. Okay. Let me minimize this. Let's look at here again. Okay, so this JWT token is generated by your protected resource. Okay, and it has three parts. The most important part is your payload, right? And remember that this is JSON object, right? This is JSON object means information in a JSON format, key value pair, right? This is a JSON object, and this one is also JSON object. Okay, so let's first discuss about the payload, which is because this is the most important part. All right. So what happens in the payload? Your uh, authorization server, right, place all the required information in the payload section, right? When I'm saying the required information, what does it mean? It means all the necessary information that your um, protected resource servers need to authorize your client. Okay, so information like user who authorized this request, like in case of me, myself, right? When this token will expire, what is the unique ID for this JWT token, right? And the most important thing is what is scope of this JWT token. Now scope, as we know, scope determines what authorization is being transferred to the client, right? So this kind of information go in the payload section, right? So if we look at our JWT token, here we can see, right? So there is a key, and this is a key, and this is value, and this is completely payload, right? And just key value pair and JSON format data, right? So if you see here what values it has, it can have it can has custom values as well, custom key value pairs as well. And remember that these key value pairs are called claims. Okay, so we have where we are, like the it tells the version of this jot token, right? And then you have JWT ID, then you have issuer who issued this token, then you have the audience. Audience is like this, who supposed to use this jot token, right? Then you have your expiry date, when this token will expire, right? And then unique ID and stuff like that, right? And then the most important part is this scope, SCP, right? This is where your authorization server mention what all uh, powers will should be given, or what all resources should be access to what all resources should be given to the client. So this is your scope, right? Yeah, so this is the payload, right? Now let's look at the header section, right? You can see in the header we have two fields. First is the key ID, so this is unique ID for this uh, jot token. And then we have the signature or encryption algorithm, right? We'll discuss about this element in detail in a while, but this header basically provide the information about your entire jot token, right? And this particular field determines how this token is how this particular token is signed, right? And the signature is the most important part of the JWT, which is used by the resource server to validate this token, to validate the authenticity and the integrity of this jot token. So, and it is validated by this algorithm. And how resource owner server will know that what kind of how it need to validate it, which algorithm it need to validate. It will know it by looking at this particular field in the header section in the jot token, right? So that's the point number 2. So now we know what's the payload and what is the header, right? Now if you see, this is in the text format, right? But when I generated the this access token, right, I received this value, right? This kind of data. So what is this? So actually what happens, as we know, that this access token is generated by authorization server, right? This is generated by the authorization server. And authorization server send this information to the client, right, in the URL, right? I hope you remember that this authorization token will be sent to the client as a query parameter in the redirect URL that your client has provided. Simple. Now we know, if we want to pass any information in the URL, we have to encode that string or encode that value, right? You must have noticed, say, suppose if you are passing a string like J space Prakash, right? Then the space will be replaced by some special character, right? That is called the encoding, right? So before this jot token is sent to your client, it is encoded by the authorization server and then sent. Okay, so what happens, your client sorry, your authorization server, right, authorization server generates the payload, right, it generates the payload. I'm sorry, just it's not working today. Okay, it generates the payload and then it encode it with the base 64 encode mechanism or algorithm, right? So it takes that JSON string and encode it, right? Similarly, it generates the header JSON data, right? And it encode that header data as well with the base 64, right? So we will have base 64 encoded URL, base 64 encoded strings, right? Just give me a second. Okay, so what I was saying is authorization server will first, it creates the JSON payload for the payload, right, and then the JSON data for the header, and then it will do the encoding, base 64 encoding for the header and the payload. Okay, so let me show this to you. So and remember that, right, this data is not encoded, sorry, it's not encrypted, right, it's just encoded, base 64 encoded, right, and anyone can decode this, right, because I have seen some people looking at this data and they say this is encrypted data. No, this is not encrypted data, this is just encoded data. Okay, so what will happen is if you open some online tool, right, and paste that encoded data, right, and see, you can simply decode it and read the actual values, because this is not encrypted data, right. These two portions means the header and the payload is not encrypted. This is just base 64 encoded data. So anyone can get this token and decode it, right, by using one of your online tool, right. For example, if I decode this, I will get this, right. So this is my, you can see that this is same value that you can see here. It's formatted, everything is every element in the new line, but here it's not, but we can do it, it's not a big deal. The point is, what I'm trying to make here is, your authorization server will generate the header, right, generate the payload in the JSON format, and then it will encode it. It will base 64 encode it, right, before it's sent to the client. That's the point number one, which also means, as per the JWT specification, it is recommended not to include any sensitive information in the jot token, like your username, password, or maybe your SSN number, because that header portion and the payload portion is not encoded, is not encrypted, it's just encoded, so anyone can read what information it has. Okay, now if that is the case, then it gives impression that jot token is not secure because anyone can read it. So it is very secure, but yes, anyone can read it. And even if someone read it, right, authorization server need to make sure that that information has some value to the protected resource, but it's not a sensitive information. For example, right, um, this jot token has unique ID for myself, right? But this unique ID may have some meaning in the resource authorization server, right? Which knows that this means this particular user. But outside that Google server or resource owner server, this may not have any value, and no one can figure out that what it represents, right? And this is not my user ID password, so even if someone finds it, it will not hurt, right? Beside that, this information, because the communication between the authorization server and the client is through HTTPS, so this is secure and passed through the secure tunnel anyways, SSL secure tunnel anyways, right? But if someone even hacks it, finds it, he will should not able to do anything because this does not contain any sensitive information, right? But next question is, how protected resource will make sure that the jot access token that it has received has originated from his authorization server or this particular authorization server, and what is guarantee that how it will know that it is not modified by the client or someone else? Because say suppose if it can be modified, I mean if the client can see it, he can modify it as well, right? So which means it's not secure, because say suppose your resource owner gives the client consent or authorization to only read files, but because it's just a JSON object, before client send this jot access token to protect a resource, he can add one more scope, but that does not happen, right? Now we are going to see why that cannot happen and how integrity and security of that jot token is maintained by the protected resource or by the jot specification. Okay, so let's look into that. Okay, now there is, in this jot token there is a one more thing which we haven't discussed yet, which is your signature. Okay, now let's see how this signature is created, right? And that is the portion that provides the security and integrity to your jot tokens. Okay, so what happens is, let's understand how your authorization server will create the signature or how it will sign the token, right? And signature, I mean the part which is really important, right? Even in the real life, if you see, if you have a bank check, right, the bank check can be public, you can take a screenshot and you can send to as many people as you want, right? But in that entire bank check, what matters is the signature, who has signed it, and that is how bank identify you, right? If you have a recommendation letter, right, from some minister or someone, right, you can publicly show to everyone, right? but that recommendation letter itself is not secure, right? But what makes that recommendation letter valuable is the signature, that the signature of the person that has provided that recommendation letter to you, something like that, right? So signature what actually matters, and that is what actually provides value to this jot access token. So before we understand how it provides the value and security, right, we have to first understand uh, like how this token is created. Okay. Okay, so let's understand that. So how this signature is created is, uh, let me show you here. So this is basically base 64 URL encode header plus dot plus base 64 URL encode payload, and then use one of the signing algorithm, right? Now we have two signing algorithm, or we can, there are two algorithm, and there are two ways to sign this jot token by the resource, by the authorization server. First is called the HMAC, and the second is RSA, right? Right. So HMAC is like your symmetric cryptography, and RSA is like your asymmetric cryptography. In HMAC, what we do is we use a secret key. We use a secret key to sign the data, or sign the in our case the jot token, right? In case of the RSA, we use public private keys, or public private key pair, to sign the and validate the signature, right? So how these two things work, let's look at here. So let's understand how this signature happens. So this is your header, this is your payload, right? So authorization server will first calculate the base 64 URL, right? Base 64 URL encoding of this JSON data, right? Now say suppose that is X, right? Plus dot, right? We have seen this dot, right? Because as you can see here, that all three portions in the jot token, right, in the JWT token, all three portions are separated with a dot sign, dot, right? So this is your header, and this is your payload, right? This is your payload, and after that you have signature part, and everything is separated with the dot, right? So when we calculate the signature, right, we consider the dot as well. Okay. Now base 64 encoding of the payload is now, say suppose, Y. Okay. Now this your authorization server concatenate this whole thing and create a string. So it's a simple concatenate operation, right? A plus X plus dot plus Y, right? This whole thing will be a long string. After that, your authorization server will create the hash of this string, right? Now, I hope you must be aware that what is a hash, what is hash function. So hash function is like a algorithm, and the property of that algorithm is if you give a string or a value to that hash function, it will always give you unique string or unique number, right? So if you give a string, it will give you a unique string, right? And the property of that hash function is that if you give the same string 1,000 times, it will give you the same hash value, right? So we use some hash function, and that hash function will give the hash code, the hash value. Say suppose that hash value is um, z. That hash value is z, right? After that, right, based on the agreement between your protected resource and the owner server resource owner server, I mean they must have agreed that what kind of encryption and decryption they want to use, whether they want to use HMAC or they want to use RSA, public private key, or the HMAC. So almost both are same, but this one is considered more secure because this here we use the private public key. In case of the HMAC, we use one single string or the secret key as the value that we will use to encrypt and decrypt the data, right? Now say suppose in case of HMAC that value is some secret key. Say suppose change it, string, change it, right? So what will happen now, your authorization server will use the HMAC algorithm, right, and will use this secret key to encrypt this hash value, right? So it will use this key, right, and encrypt it. Encrypt it, right? Now say suppose after encryption, right, after encryption that value is a, right? That is what we call the signature, right? So this signature will be added after the payload with the dot uh, uh, here. Say suppose this is after base 64 you are encoding, and now this will be your a, right? So all these three value will be sent to your client as a jot token. So it will have base 64 URL encoded header, base 64 URL encoded payload, and then your signature. It will be provided to client. Now client will send the same value to the protected resource, right? Now the final phase where protected resource means this guy, right? Protected resource need to validate this token before it give access to the client. You need to make sure that it is not modified with anyone, and it also need to make sure that this token is provided by the his own authorization server, not by some random person, right? So now let's see how it will do it, right? So what your resource owner resource server Say suppose this is your here resource server. Resource server, right? What it will do is it will take the entire jar token, right? First it will take the first it will take the okay first it will take the in the entire jar token, right? So this is your complete jar token, right? In this jar token it will first take the signature. Okay, what it will do, it will take the signature and it will decrypt this signature with the same method, right? And with the same key in case of the HMAC, right? Which is used by your authorization server to encrypt it, right? So if say suppose authorization server and the resource server had decided they will use the HMAC, right? And this as a key, what it will do is it will decrypt this encrypted value with the same key, right? Now if if we use the same secret key, right? Your authorization server, your resource owner, resource server will able to decrypt this, right? Correct, because it is using the same secret key, right? So in that case what will happen when it will decrypt it, it will get the it will get the hash code that was originally calculated. It will get the Z, right? This Z is same, right? That your authorization server calculated, right? And it encrypted it to with the secret key and got the A. Now resource server will decrypt it with the same key, so it will get the Z, right? So that's the first part. And the second part, what it will do is it will take your header, encrypted header, right? Sorry, not the encrypted header, base 64 encoded header and the base 64 encoded payload, right? With dot as a in between and can concatenate it, right? Hmm? And it will calculate the hash code, right? It will calculate the hash value of this string. Okay, so say suppose it use the same hash algorithm and calculate the hash value. So if it do that on this string, right, it will get some value, right? Say suppose that is y, right? Next what it will do is resource server, it will see if this value and the decrypted value is same or not, right? If it's same, right, if it's same, then it confirms that this particular jar token is not altered by anyone and it has been created by his own authorization server, right? Just imagine if say suppose before sending this jar token to the authorization server, your client, right, update something in the payload. So say suppose in scope there was only one scope which was a read, he had one more scope write, right? So when he will send this value, when he will send this value to resource owner, right? I mean he added one more scope, right? And then he encoded with the base 64 and sent to the resource server. What resource server will do? When it will validate, it will calculate the hash of this new string, right, which has right in the scope. Okay, so this time when it will calculate the hash, right, it will be, say suppose m, right. This m will not, definitely not match with this z, right. And if it's not matching, it means the string was altered. So your authorization server will know, yes, this is not what my sorry, your resource server will know that this is not what was produced or generated by the authorization server, right. Validation is done. Now say suppose your client gets this authorizations get this jot token from some other authorization server. So if that, in that case, your authorization server, right, that authorization server will not have the same key, right, same secret key. So it will encrypt it with his own secret key. So, when that actual jot token will get to your resource owner, resource server, right, it will try to decrypt that signature. So obviously it will not able to decrypt it with the same key. And even if it decrypts it, right, it will not match with the hash of the your header and payload, right. So again, which means your resource server will know that this is not the right key, right. So this is how your resource owner resource server validate the token, right. And so everything works same for RSA as well. The only difference is um, your authorization server, right, encrypts the hash code, hash value with the private key, right, and the public key of that private key will be on the resource server. So your resource server receives the jot token, right, it decrypts the signature with the public key, right, which is z, and then in the same way it calculates the hash value of encrypt encode base 64 encoded header and the base 64 encoded payload with dot in the middle as a string, right, and calculate the hash value, right. And then it matches. If that hash value matches with the decrypted signature value, then it assumes the token is not altered by anyone and it's good to use. So this is how your authorization server validate the jot token, right. And it makes sure that it is originated from the right authorization server, and it also makes sure that it's not altered by any middleman or by the client. All right. Yeah, so I think this is about the JWT.